Hello, welcome to this part of a tutorial. Today we're going to look at how to model a slotted liner in Petroleum Expert Prosper. Slotted liner is one of the open hole completion methods, one of the sun control methods in open hole completion. Okay, I think that's more appropriate. Okay, so first, before we continue with the modeling, let's look at the data we have available for this model. You look at my screen, I've provided the data which we'll use, the PVT data, the equipment data, the temperature profile, the IPR data, and finally, the liner parameters. So the method for this modeling is very similar to the models we've developed in time past. The only difference will be in selecting the wall completion type and the sun control type. So let's move into action immediately. So like every other model, we have to start with the options, where we set our system summary. I'll leave every other thing at the default value except the wall completion. The type, I'll change it from cased hole to open hole. And then I'll change the sun control from none to slotted liner. Okay, so once I've done that, I am good to go. We can continue with imputing other parameters. The next parameter which I'll have to impute are the PVT data and the others. So it's pretty much the same thing we've been doing in other tutorials. You just follow as I key in the parameters. The GR is 400. The oil gravity is 30 API. Gas gravity is 0.75. Salinity is 80,000. There are no impurities in our model, so we'll quickly move to the equipment data. I'll select all and then deselect the surface equipment, and all I have to do is to supply the data for them. For the deviation survey, if you look at the data we have here, it's a typical data for a vertical well, starting from the surface at 0 feet and ending at 8,000 feet. If you look at it, you'll discover the measured depth MD is equal to the true vertical depth, the TVD, and that's very characteristic of a vertical well. So we have since we're modeling, and since our model is open hole completion, there'll be no need for the casing, so I'll discard the information for the casing. I'll just input the information for the tubing, but our tubing has to get to TVD, so I'll set the tubing at 8,000 instead of 7,800 as it has been stated here, and then I'll set the inside diameter that will not be changed. Okay, the roughness, is it the same roughness? Okay, 0.00, so I'll change the roughness 0.0018. Done with this. The temperature profile, the temperature at the surface is 70 degrees, while at TVD we have 200 degrees Fahrenheit. Our overall heat transfer coefficient is 8 from the information shown here. Okay, we'll leave these where they are the heat capacities. The next information which I'll have to supply is the IPR data. For this model, I'll use the Darcy Interskin by hand model. The pressure is at, okay, what are the values? 4,000 for pressure, 4,000 psig. Temperature is at 200. Water cut is still at 0. So the input I'll have to enter the reservoir model. The permeability of our reservoir is 150. The thickness of the pay zone is 100 feet. The drainage area is 340 acres. The airship factor is 31.6, and the wellbore radius is 0.354. That's approximately 4.3 feet. I mean inches, sorry. This is in feet. So the next information is the skin, which we are told is +2. Okay, and then the liner parameters. So that will be inputted in the sound control tab. Okay, the production interval is the entire pay zone, which is 100 feet. The liner inner radius is 0.3. For the outer radius, we have 0.34. So it's actually the thickness of the liner is very small, 0.04 feet. Okay, the slot height, the height of the slot is 4 inches. The slot width is small, 0.01 inches. The slot density is, we have 3 slots per feet. So for the entire 100 feet, we have 300, right? Yeah, 300 slots. Okay, the screen outer radius is 0. We're going to use 0 because we want to ignore the outside radius of the screen. We do not need that for our simulation. This is required for screens like the pre-packed screen and the wire-wrapped screen. But since we're dealing with slotted liners, we have to ignore this. It's not required for our model. So I'm going to use 0, or I leave it blank. According to the information here, it said only require for screens blank or 0 to ignore. Since I do not want it, I'll just put 0. You can also leave it blank to ignore the value. It's not actually required for what we're doing. So the next thing is our outside permeability, which is at 50,000. The turbulence factor is 0. We want to ignore the turbulence factor too. Okay, so we're done with that. The next thing which you have to do is to calculate. And after calculating this, what we have the absolute open flow to be 23,000 stock-ton barrels. If that is possible, how much barrels do you think we'll be able to produce? So let's go into the main thing. Let's check what we can produce, what this well can produce without assistance, without artificial lifting. So for that, we're going to go to calculation, system, IPR and VLP, 3 variables. We'll set our top node pressure according to information here to 250 psig. Oh, sorry. 250. Okay. So I'll continue, and calculate. We're done calculating, and we're told we can produce 10,000 out of, was it 21 or 20? Out of about 21,000 stock-ton barrels, we can produce 10,000. I think that's fair enough. Okay, so that's all we have for the simulation. You can view other details about the solution when you click on this. Okay, and that's what you have. And then you can always plot. So once you plot, this is what we have. You're plotting liquid rate. If you're looking for just oil rate, you can come here and change that to oil rate, and you go done, and you'll see that. And of course, if there are other variables you need to plot, let's say for instance, you need to check. I don't think there's any other thing, but just for demonstration purpose, let's say you need to check your perforation at this, the DP change in pressure across the skin perforation. Okay, that's all you have. So just go finish, and that's all. That's just, it's as simple as that. How to model a slotted liner. So thank you very much for watching our tutorial. Feel free to share the tutorial. Feel free to like, share the tutorial, and don't forget to subscribe. And then do me a favor, please watch the ads, please, so as to get to support these development. Since you're getting it free, at least you ought to, if you have any means of appreciating, you should. And one of the ways I'm asking you to appreciate is by just watching and interacting with the art which you'll be seeing on these videos. Thank you very much. See you some other time.